So for our project, we chose to do a classification task where we could predict whether a patient would or would not have a stroke based on a variety of patient information. We trained and tested our model on a data set of patient information where stroke incidence was pre-specified, and we primarily aimed to maximize sensitivity followed by accuracy. We felt that sensitivity was most important to make sure that patients who are at high risk of stroke can take preventative measures to reduce their risk of having a stroke. Although it would be nice to eliminate false positives as well, we felt that they wouldn't be as harmful since they might just mean that patients would be more mindful of their health. So we chose to use the stroke prediction dataset, which we found on Kaggle. The dataset contained 11 different clinical features that could potentially factor into stroke occurrence, and then stroke incidence was also noted in a separate column as either a 0 or 1. We started our analysis by researching the different features and comparing how the distributions of the features differed when comparing the cases with stroke and the cases without stroke. So the first two features that we looked at were hypertension and heart disease. According to the US National Library of Medicine, hypertension is the most prevalent risk factor for stroke. In the graph on the left, we can see that the proportion of patients with hypertension is much higher in the stroke cases. And then moving to the graph on the right, we see the second most important risk factor for stroke, which is heart disease. And here we can see again that there is a greater proportion of patients with heart disease in the stroke cases. The next features that we looked at were gender and age, and according to Johns Hopkins Medicine, stroke occurs more often in men than women. Although our data set has more females than males, in the chart on the left, we can see that the proportion of males to females is greater in the stroke cases. Additionally, for each decade of life after age 55, your chance of having a stroke more than doubles. In our data, we found that 70 to 80-year-olds were the largest group in the stroke cases, despite not being the largest group in the dataset overall, as you can see in the middle figure. And combining these factors, we can also see that female patients around the age of 75 had a much higher number of stroke instances than any other group. Another risk factor of strokes is diabetes, and this was captured through the average glucose level column in our dataset. According to Mayo Clinic, a blood sugar level of 200 milligrams per deciliter or higher suggests diabetes. And here we can see that in the stroke cases, there's a much higher proportion of people in the 200 and above range. So after this initial exploratory analysis, we'll move into the actual training and testing of our model. So our dataset actually had almost 20 times more records of patients without stroke than with stroke. So in order to create a less biased model, we upsampled the stroke records so that there would be equal numbers of each classification. Additionally, because all of the included features seem to be prevalent risk factors for stroke from our research, we included all of them in the model. After testing many different classifiers, we ultimately chose the random forest classifier to represent our model. And we made this choice based on performance, first through sensitivity and next by accuracy. As you can see, our model had a recall score of exactly 1 and an accuracy of 0.99. So this was very good since there were no false negatives and very few false positives. So now I'll pass it on to Leanne to talk about feature selection.
So, as Sabrina said, both accuracy and recall scores of our initial model were very high, which seems almost too good to be true. And we know that random forests tend to have more accurate predictions, but there could be the potential of overfitting. So, we'd like to pick out a few features that are more correlated with stroke to mitigate the overfitting problem. So we set our threshold at an absolute value of 0.1, and that leaves us with 7 variables: age, ever married, average glucose level, heart disease, hypertension, and 2 work type variables. We used upsampling here because, again, rows with stroke versus no stroke is about 1 to 20. If we sample down, we would lose a lot of information about the no stroke group. Now we passed a new feature into the random forest module, and here are the results. The recall score is the same, which is 1, but the accuracy score was down by 3%. This could be due to the fact that the first model was overfitting. So now we're thinking, how can we add values to this project, given that many scholars have used this dataset in their research? We noticed during data exploration that female patients around the age of 75 have especially high number of stroke instances. Existing research has shown that female stroke victims have a higher rate of death. 60% of women died from stroke compared to 40% of men. So we'd like to focus on female patients over the age of 70 and come up with a model that predicts stroke in this specific group. So we balance our data by upsampling for the same reasons, feature selection to avoid overfitting, and we chose random forest again because it produced the highest recall and accuracy scores. So here is our performance for the new model. The recall score is 90% and accuracy is 95%, which indicates it's a pretty good model. However, we do need to keep in mind that our dataset was very small, so it might not be the best representation of all elderly women in the country. So what can we do to further improve our models? As I mentioned, higher accuracy and recall can be attributed to the fact that upsampling such imbalanced data duplicates the minority rows, which would lead to overfitting those rows. And here are some steps we can take to improve our model. First, we can gather more data from various sources to increase our dataset pool. Secondly, we can add more variables and features such as race, blood type, and so on. And finally, we can focus on the deadly stroke instances by identifying features and patterns within those groups. That concludes our presentation. Thank you for watching.